now let's see the fourth part of this problem. So now we're going to talk about the second method to prove this part. Okay? So first, let's see an example. Another example, and this example is 15. So 15 is equal to 3 times 5. So what we're going to do is let's draw out the picture. 3. So let's see. Every row has 3 numbers. 1, 2, 3. And 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So these. Okay, let's write it out. Now let's see here. Let's see here. So first let's see 5 of 3. 5 of 3. How many numbers here? So let's see here. 5 of 3 has 2. So we can think that's 2 column. 2 column. And you see, what's 2 column? Because you see 3 right here, this column no need, because this column of course is a multiple of 3, and right here it's 2 column. This 2 column we care about it. And this column no need. Right, in this 2 column, let's think. Let's see here. How many in every column? You see, every column that has only one number that is not co-prime with A. Sorry, not co-prime with 5. With 5, right? Okay, so other numbers. How many of them? That is, of course, 2. Where did this 2 row come from? This 2 row, how do we calculate it? That is 5 of 3, right? And then times, you see every row, that's 4 minus 1, right? 4 minus 1, that's equal to 5 of 3, right? 5 of 3, and times 5 of 5, right? So that's easy, right? And this is the first example. It's very easy, but we don't know how to solve all of them. So let's see another example. If it's, I don't write down, so I just write it's, it's 3t2 times 5t2. Okay. I just write it out because it's 3t2. They're going to just, because 3t2 is 9. So 1, 2, from 1 to 9. And then let me like 10, and then blah, 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 blah. I don't write it that, okay? Maybe here's 18. Yeah, it's 18. Okay, and so on, right? So on. Right, okay. Now how do we calculate this problem, right? So first, 9. So how many rows we need to calculate about this? You know, is, we'll just write the first row. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So how many rows you need to care about? This row. No, 3, 5 row, 7, 8. There's others we don't need to care about it, right? These rows we need to care about it. Okay. So how do we find out that? Because it's very easy here. You see here. This one is 5 of 9. So what we do next is each row, how many of them? But first, don't think of that. First, let's think a problem. You see, every 20. You see how many in all of them? How many numbers is co-prime with 25? Let's think, because in 25, these numbers, and because 1, 2, 3, 4, 5, in these numbers, only 5 is not co-prime with 5. Only one number. So 25 is 5, this multiple of 5. So it has 5 numbers in 25 is not co-prime with 25. So, and we have not this, each column has 25 numbers, and right here we don't know that. I mean, right, you don't know never how much here, maybe somewhere and just stop here, right? And these 25 numbers has what? Has 5 numbers is not co-prime with 25. And then 125, the second 25 numbers, and the third 25 numbers, and it have 9 25 numbers, 9 crew of 25 numbers. And so 9 times 5, right? 9 times 5. So how do we put it? Each row, each column, because it has 9 columns. So each column has 5 numbers that are not co-prime with 25, right? So 5 numbers. So what we do is 2 times 25, because in each row there has 25 numbers. So 25 minus 5. And because it's very lucky, or I mean, it's lucky, right? And 25 numbers, and then minus 5. 5 is numbers from 1 to 25, and that is the amount of the numbers from 1 to 25 that are co-prime, not co-prime with 25, right? So we minus, use 25 to minus it, so we have the amount of the numbers in 1 to 25 is co-prime with 25, right? And that is equal to 5 of 9, right? 5 of 9, and then times. So this part is what? Is a 5 of 25. And this actually is, we should write it to 5 of 3 to the 2 times 5 of 5 to the 2. Right, so this is our, this is our proof. So if you will, sometimes you ask, hey, so what about, you see, the problem we're going to prove here, you see, actually you have proved this problem, but the answer we're going to use a lot of them. So how do you use? You only put 2 of them. So let's see example. And this but I just don't 3 of them. So let's try it. If it's 3 to the 2 times 5 to the 2 times 7 to the 2. You'll find it. It's easy. First, you think the numbers from 1, and then every row has 3 to the 2 times 5 to the 2 numbers. This much numbers. And each column has 7 to the 2 numbers. Okay. 7 to the 2 numbers. So what we do now is, let's see. So the problem is all we have right here is, so how do you calculate how many rows right here? You see, so 1 to 3 to the 2 times 5 to the 2. So how do you do it? Yeah! We have this way, right? We can just do it again. So for 4 numbers, do it again and again. We got an answer. And if it's a lot of, like here, 10 of them again. And finally, you have 2 numbers and you can solve this problem, right? And you get bigger, and you still can solve this problem. So that means we have solved this problem. We have proved it, right? We have proved this problem, right? Like this way, right? Actually, this way is easy. We just use the graph, and we can find out this way, right? Okay, so we have proved this problem, right, on the second lesson. Now let's have an easy proof of when m and m, both of them, their exponents are equal to 1. So how do we prove it? So first, I have drawn a picture of, like here, first m, 1, 2, point to m, and the second row, m plus 1, m plus 2, point to 2m, and so on right here. It's n minus 1 times m plus 1, and then next number is n minus 1 times m plus 2, and so on to n times n. Of course, there's a row right in here, has second right here. We can say it's the row, it's the row of k. The first number can say it's the row of k. And k, and then m plus k, and so on to n minus 1 times m plus k. Okay, so now we're going to prove it right here. Let's see here. Okay, first let's see. Right, in that row, we have two numbers. The first number is lm plus k. L times m plus k. And the second number is L dash times m plus k. And now let's set here. These two numbers have the same remainder when they mod when they mod n, okay? And so what we do is we can write their congruent mod n. Okay, so we suppose this one. We suppose it. So what's the next step? So of course the difference is congruent 0 mod n. So of course that means the difference is a multiple of n because they had the same remainder. So what now do? You see, they have the same remainder. So and their difference, they have the remainder has been deleted, and and this still has been deleted some multiple of n. So the remaining is some multiple of n, right? So that means right here, of course the difference we can calculate out. K has been cancelled out, so it should be L minus L dash times m, and this is congruent to a 0 mod n. And so what's now here? Because you see, m and n are co-prime, and this is the condition of this problem right here. See that? Okay. So what's the next step? So that tells us that, see here, that tells us n is the divisor of L minus L dash. So that tells us, because you see here on the picture, the multiple right here, the L and L prime, they are from 0 to n minus 1, right? And so that means they are not allowed to be so big. They're not allowed to be big enough, right? And the difference can't be a multiple of, because the difference needs to be a multiple of n. They can't be any multiple of n except the 0 multiple of n. So that means L is equal to L dash. So that means right here, of course, L is equal to L dash. That means right here, that tells us n, right, in this column, in each column is the same. In each column, there has only one number is not co-prime with n. So that means there has 5 of n numbers in each column that is co-prime with n. So that means, let's times here. So how many columns we need to care about? 5 of n columns we need to care about, because other columns, they even not co-prime with n. So they're not even co-prime with n. So m. So we don't need to care about it anymore. So we only need to care about how many columns. 5 of m, this amount of columns we need to care about. So this is the whole answer we got. So this is the first, we're going to find this problem, right? So that means we're going to find 5 of m, and times m is equal to this one. So we have proved, of course we have easy proof we only have the easy proof for what? N and M, their exponents are both equal to 1.